Hi everyone, today's lesson 3, the quadratic formula and complex solutions. So when I say complex solutions, we are plugging numbers in like we normally do into the quadratic formula, but our answers are going to have square roots or radicals that don't simplify, meaning that there's not a perfect square underneath that radical. So yesterday we learned how to simplify those radicals, so we're basically combining lesson 1 and lesson 2 to create lesson 3. So let's get started with today's notes. Today we're on lesson 3, right here. Lesson 3, the quadratic formula with complex solutions. Your learning target for today is I can solve quadratic equations with complex solutions using the quadratic formula. So as I mentioned, this lesson combines lessons 1 and lesson 2. So lesson 1 was the quadratic formula, and lesson 2 was simplifying radicals. So you'll see the connection in a few minutes. So we're going to solve by using the quadratic formula and then simplify the radicals if they are not perfect squares. So in lesson 1, all of the radicals or the square roots were perfect squares. They came out nice. Today they are not going to. So we're going to have that extra step. So if you remember, when we start solving quadratics, we always have to set the equation equal to 0 or replace y with 0, because remember, we're finding the zeros. Other words for zeros are roots, solutions, x-intercepts. Then we have to identify our a, b, and c values. A is equal to 1, b is equal to -8, and c is equal to 14. So now I'm going to copy and paste the formula. Now, if you notice, I have two sections here, one side on the left and one on the right, and that's just because these are going to require a lot more work, and I figured we might appreciate having work side by side rather than just all on top of each other. I'll also move that off to the left. And I'm going to make things a little bit smaller. Oh, that's really tiny. Probably just because it's a fraction. So I lied. I'm going to change that back to 14 at least. Okay, so we're just going to plug in. I like to just plug in right from my formula here using those parentheses. As you know, parentheses super important. So my b value is -8. See, we got that double negative again. Our a value is 1, and our c value is 14. In our denominator, we've got 2 times a. Oops. By the way, if you ever do anything like that, accidentally delete everything, Control-Z takes you back, or you can always do the undo button. A value is 1. Okay, so let's start to simplify. As I mentioned on lesson 1 day, that we simplify one piece at a time so you don't overcomplicate things. So here we've got a -8. A double negative turns into a positive. So we have a +8 plus or minus. Now, when we type this into our calculator, again, we do not type in the square root. We are just simplifying what is underneath the square root. And we should get 8 underneath that square root. Did it again. Okay. There we go. And hopefully you're already connecting that 8 is not a perfect square. You can always double check that by looking at, and I'm also simplifying the denominator there. You can press second x squared, that gives you your square root. Square root of 8 is not a pretty number, so that means it's not a perfect square. So what I'm going to do is I'm going to go over to this side and I'm going to simplify radical 8. So if you need to refer back to the reference sheet on how to simplify radicals, you can do that. Remember, we find factors of 8. And so I know I'm just going to list them all. We got 1 and 8 and 2 and 4. Not a lot of factors for 8. So our perfect squares are 1 and 4, largest perfect square being 4. So we're going to break that down. So we have radical 4. We always type in the perfect square first. And radical 2, because 2 times 4 gives us that 8. We can simplify the radical 4. That turns into a 2. I'll put this all in equation. 2, and then radical 2 stays the same. So that's our simplified radical. So what I'm going to do is I'm going to replace radical 8 with 2 radical 2, because those are now equivalent. I'm actually just going to continue this line of work here. So we have equals. I'm going to copy and paste. So instead of 8 radical 8, we are going to do 2 radical 2. Okay, so now it is simplified, the radical is simplified, but now we need to figure out if we can simplify that entire expression. So before, we're not even going to split, you know how yesterday we split, or not yesterday, on Monday we split 8 plus 2 radical 2 over 2, and then 8 minus 2 radical 2 over 2. We're not going to do that today because we are leaving our answers in simplest radical form. So what that means is we are not simplifying. The only time you actually split and solve is if it asked for a rounded answer, like if it said round your answer to the nearest hundredth, because then we can take that crazy long irrational number and round it. Okay, so what we're going to do right now is I'm going to split this fraction. Okay, right now I'm just going to write it first and then hopefully we'll make some sense of it. I'm going to split this fraction into 8 over 2. That's this piece right here, 8. Can't just highlight the 8 for some reason. So the 8 right there over the 2. 8 over 2. And then plus or minus 2 radical 2 over 2. You know what? I bet I can just copy this piece. Do you see how this piece right here is equivalent to this piece? We prefer to write it like this, but when we're simplifying, I want you to clearly be able to see what like each piece is looking like. So when we simplify things with radicals, well, first of all, this 8 over 2, we can easily simplify that. We know 8 over 2 is 4, 8 divided by 2, plus or minus. Now, when we simplify this radical expression, the radical stays. You do not change what is inside the radical, okay? So we're just looking at this 2 on the outside, this 2 right here, 2 over 2, okay? So 2 over 2 is just 1, so that means I would have 1. Radical 2. Now, 1 in front of something is kind of like saying 1x. We really don't need it there. So this is just 4 plus or minus radical 2. The denominator of the 2 simplified so that we don't have a denominator anymore. So this right here is our final answer. 4 plus or minus radical 2. Now, this is left in simplest radical form. If the direction said to solve and round to the nearest tenth, then we would type in 4 plus radical 2 into our calculator and round, and 4 minus radical 2 into our calculator and round. Okay, so let's now take a look at the next one. We'll do one more together. Again, first step, setting the equation equal to 0. Then we have to identify A, which is 3. B, which is -6, and C, which is -5. I'm going to copy and paste this one here. If you need to copy and paste the original formula up here so you know what variable is what, you know what? I think that's going to be a better idea. So let's do that. I have the formula memorized, so that's why I do that, to kind of skip a step. But you guys should not be skipping steps at this point. So I'm going to change that font size to 14. I'm just an organization freak, so I'm doing all this extra stuff here. You want that on the left. Okay, so our B value, -6. Minus 4 times A, which is 3, times C, which is -5. And A is 3. And I'm going to copy and paste. And let's simplify that. The double negative goes away. Turns that -6 into a +6. And again, typing everything into your calculator that is underneath the radical. Do not type in the radical. Go ahead and do that on your own right now. I got 96. Hopefully you did as well. And then in the denominator, when we simplify 2 times 3, we should get 6. Now we want to simplify that radical. So the square root of 96, if you type that into your calculator, it is an irrational number. It is not a perfect square. So that means we need to take the square root of 96. That means we need to take the square root of 96 and we need to simplify it. We need to take the square root of 96 and simplify it. So again, I'm going to show you the calculator trick since we might not know our factors of 96. Go to second graph. Look at all those pretty numbers. So we got 1 and 96. Neither of those are perfect squares. 2 and 48, 3 and 32, 4 and 24. So I see 4. I know 4 is a perfect square, but let's see if we can get a larger one. And then I see 16, 6 and 16, that's even larger. So looking good so far, and I'm going to keep going, and I see 8 and 12. And then 12 and 8, so those are repeating. So 6 and 16 are my magic numbers. So I've got 16, you got to write your perfect square first. And times 6. And simplify our square root of 16 to 4. If you notice, I'm just copying and pasting so I don't have to keep inserting the radical. So this should be 4 radical 6. Okay, so what I'm going to do now is I'm going to replace that into my formula here. I'm just replacing the square root of 96. So that instead of instead of the square root of 96, we have 4 radical 6. Okay, so now let's go to another line and let's split this. So we want to individually see each term and how we need to divide out that 6 to each term. Okay, so we've got 6 over 6. Plus or minus 4 radical 6 over 6. Doing my copy and paste trick. Okay, so 6 over 6 hopefully is easy. That's 1. Plus or minus. Now, when we look at this expression right here, we do not touch radical 6. We do not touch it at all. We have 4 over 6. Now, 4 over 6 doesn't simplify nicely, but you can simplify it into a reduced fraction. So again, if you want to do, you probably know how to do this in your head, but let's just second quit out of this mode. If we do 4 divided by 6, it is an ugly number. So let's keep it a fraction. We press math, enter, enter, and we get 2/3. So you can either write it as I'll write it two different ways here. So you can write it as 2/3 and then the radical 6 after it, like that, because technically the radical 6 would be in the numerator. Or you can write it as 2 radical 6 over 3. And that's our final answer, 1 plus or minus 2 radical 6 over 3. Okay, so we did 2 examples together. I want you to give numbers 3 and number 4 a try on your own. Okay, let's take a look at number 3. Number 3 was actually simpler than the other 2 that we did together, mainly because the radical 5 that you get at the end cannot be simplified as a radical. And when you split this, we cannot simplify that any further. Okay, we want to keep those improper fractions, by the way. If you're thinking -5 over 2, we want to keep that as an improper fraction. All right, number 4. We get radical 12 underneath the square root. That simplifies to 2 radical 3. Now, one thing I do want to mention, if you got this as a final answer, that is 100% perfect. Even if you put a 1 in front of the radical 3, that is still correct. It's just like writing 1x. We really don't need that 1. But if this was a multiple choice question, this would be the only option because that's the condensed version of writing the answer. Mathematicians are lazy. They want to write as few pieces as possible. So it would be written as one fraction like this here. And that's all we got for today. We combined solving quadratics with the quadratic formula with simplifying radicals. Make sure you self-assess for today's lesson and let me know if you have any questions.